The following parallelogram, Casey wants to prove that the triangles ABD and ACD are congruent. Happy days. So she's going for BAD. What's the angle BAD? BAD is the dot. Would you agree with that? B to A to D. And the other one is ADC, A to D to C. Now, you guys would have remembered this. Z. What is Z stand for? Yes. So the two of these are in fact alternate angles. I hope you all got that right. That anything that looks like a Z or an N, provided they're parallel lines, are alternate angles. So all you had to write here was alternate angles. Happy days. Alternate angles. Okay. Now, the next thing it goes for common to both triangles. So that's angle. So it has to be a side because angles are has to be the side AD. Would everybody be happy with AD? That's the common side, isn't it? So it's quite simply AD equals AD because it's a common side to both triangles. Okay. Finally, opposite angles in a parallelogram are equal. If we're going for ASA, which it looks like, doesn't it? If we're going for ASA, it has to be angle, side, and then the other angle has to finish it off. So, I think it's going for... That's silly. It's a silly way of doing it because we could have just went for alternate angles again, couldn't we? Would you agree with that? Okay, would you agree I could say that the blue x equals the other blue x? For what reason? Yeah, but that's not what they do. They decide to make it a bit harder because it's a mock paper and not a junior cert paper. And what they're actually going for is this. They're actually going for this red angle equals this red angle because they're opposite angles in a parallelogram. So it's ABC, angle ABC, angle ABC equals angle ACD, which is sort of silly. And then what they went for after that was the remaining angle, or the third angle, is the two green ones here. Because if two angles are the same value, they have to add up to 180. So that means the green ones have to be the same as well, because all three angles have to add up to 180. So we're going to say BDA equals DAC. Congruent, and then this is congruent by what combo, guys? ASA, because that was your third A was there. ASA. Now, we all good with this one, guys? Now, if you remember this one back in the day, what I would have said it was the following, right? So I'm going to show you the rule for this one. Okay. Here we go. So, lads, here we go. You ready? Okay. So here it is. If an angle stands on an arc, so do you see these two legs are standing on an arc? Does everybody know what an arc is? What is an arc? It's basically like a pizza crust of a pizza slice. See this red arc here? That's called the minor arc. Does anybody know what this blue one's called? Major arc. I gave a grind recently and we're doing this exact same stuff. Minor arc, major arc. Now, would you all agree it's standing on the minor arc? Now, would you all agree that the angle at the top is also standing on the minor arc? Agreed? So, if I say that this is, for argument's sake, 100 degrees, what do you think this angle has to be? There's a rule for this. Half it, which is 50. Only if it's on the circle and only if the other one is at the center of the circle. Is that okay? If I move that off the circle, this is pretty much the grind I gave, word for word. Alright? If I move it off the circle, is it 50 now?
Yeah.
No, because it has to be on the circle. Okay, so just to hit this point home again, what happens if I change this to 110? What's it now? Up top. Would you all be happy it's 55? Now, here's what this question takes on a life of its own. Doesn't do it in this question, but here we go. What happens if I set this to the diameter? Okay, so for argument's sake, I'm trying to turn it into a diameter. What now? What does it look like? No, but what does that angle look like to your eye? It is 90. Do you know why? Because that's 180. Okay? And this is called angle in a semicircle is always 90 degrees. Now it gets really awkward when I bring it above 180. So if I go, it's called a reflex angle. If I go for a reflex angle and I basically extend this above the 180 mark, does the angle on top still look like 90? It still looks like 90. Okay, I'll make it more extreme so. It still look like 90 now. It doesn't. Right? 90 is like this, like a T. Alright? And for argument's sake, does this bottom angle look like 180? It looks larger than 180, right? I'll call it 240. So what do you think this angle here is then? 120. So that takes it from regular triangle to straight and then to reflex. So it follows the same pattern. So in this case, can anybody tell me what those two blue angles combined are? Do we have to give reasons?
7.
What? 72. So what we'll say is angle ACB is 72 degrees. Happy with that? Now, what type of triangle is this one? Why is it isosceles? Huh? Yeah. So I say this angle's 42. Why is it 42? Because it's isosceles triangle. And what's 72 take away 42? 30. And what angle does it even want from me? It wants BOC. B to O to? The goal is the red triangle. The red angle. But what's this angle down here? Also, because it's another isosceles triangle. And what does that make this angle in here? Okay. Alright. So is everybody happy with 120? Alright. Oh, look. Oh, it wants me to do a perpendicular bisector. That's useful. Because I have to do a perpendicular bisector of A to D. Sorry. I have to do BC. Everybody see BC? You guys practiced this yesterday, didn't you guys? Some of you did it yesterday. So look, here we do. Who knows how to cut that in half? Okay. You grab it and you go above halfway. Agreed? You go one above and then you go one below. So drag it all the way down here and do the one below. Above and below. Now what do we do next? Other side. See the tip of my compass right there? Once. Oh, what did I do there? Okay. Then I'll just grab this and then I'll just change it here. There you go. Twice. Oh, I did the thing again. Alright, here we go. And then we draw a straight line, don't we? Now, how would you know? I think I lost a mark there, do you? Do you think I'm right through the X? No, it's harder for me. It's a bit clunky here, but that's it fixed up, right? And if you were to measure that, what would it be? Exactly halfway, wouldn't it? And that's a construction, and that's easy marks, okay? Marks that you couldn't get before. Okay, now what does it want from me next? It wants me to prove that ADB is the same as ADC. It wants me to prove they're similar. It doesn't even want me to prove they're congruent, which they are. It wants me to prove that they're similar. Okay, so here's the issue, okay? So it wants the left triangle has to be equal to the right triangle. Okay, would everybody agree that this is 90 degrees? What angle is that? BD, BDA? Okay. Oh, it already does that. It says they're both 90 degrees. Shh. Okay, guys. Next thing. It's an isosceles triangle. So what does that mean about this angle here and this angle here? So we say angle ABC equals, sorry, ABD equals ACD. And what's the reason? Isosceles triangle. Okay, last one. We call this third angle. What's third angle mean? Third angle adds to 180. What is the third angle? This red one here and this red one here. So that's the angle BAD. What's the other one? CAD or DAC, yeah. So we proved that all three angles are the same. Okay, happy days. Let's move on. Okay.